All right, so today we're doing 13.1, which is probability. So calculating experimental versus a theoretical probability. So to warm up, if you flip a coin, what's the probability of flipping tails? It's going to be 1/2 or 50%. So this next question, we want to flip a coin 6 times. So it's the way we flip it and we get tails and then heads and then tails and then tails and then tails and then heads. So here you can calculate this. What is the probability of tails now? This was 4 out of 6, which is not the same as a half. This would be 2/3 or 67%. So this would be your experimental probability because you actually did something and you see what happens. This would be your theoretical. So what you expect to happen or what should happen, not necessarily what does. So lots of definitions today. An event is something that happens or something that you do. So it's just like what's going on. So something that happens or something you do. So an example, you could do flipping a coin. It could be rolling a die. It could be hitting a baseball, winning the lottery, anything that you want to figure out a probability for. The outcome, this is all possible results. So the possible results of an experiment. So if you're flipping a coin, you could have heads or tails as your outcomes. You have 2 options. The sample space is your list of all possible outcomes. So for example, if we wanted to list the sample space of grades, you have an A, A minus, B plus, B, B minus, etc., which then would be a total of 12 outcomes if you count them all. So just be your list of everything that could possibly happen. A favorable outcome is what you want to happen. So the desired outcome. So if we said here we want, say, a grade of a B or better, your favorable outcomes would be a B or a B plus or an A minus or an A. So you'd have 4 favorable outcomes. All right, so then the next definition is probability. So the probability, you would write it as P of some event. So flipping a coin and getting heads, or getting a blue car in the parking lot. And how you calculate it is you want to take the number of favorable outcomes or the number of things you want to happen. So favorable outcomes divided by your total outcomes. So the example I'll put on the bottom this time. But if we wanted the probability of a B or better that we had from the last slide, there was 4 possible ways to get a B, B plus, A minus, A. And then there was 12 possible grades, so 12 different outcomes. Forgot out here, outcomes. And then you could simplify this to 1/3 or 33.3% would be the probability of getting a B or higher. Experimental probability then is calculated by actually doing an experiment. So your probability calculated by doing something. So example would be rolling a die and seeing how many times you get like a 2. Theoretical then is like what should happen. So this is calculated using like mathematical reasoning. So what should happen mathematically. So the example would be here is it's 50% probability of heads if you flip a coin. Like that's what you should get. If you actually flip a coin, it may not come out to 50%, but that's theoretically what should happen. Okay, there's some actual examples here. Quality control inspectors sampling 500 LCD monitors and finds defects in 3 of them. So what is the experimental probability? We're going to take the 3 that had defects divided by the 500 they looked at, and that will give you your probability of 0.006, which is then 0.6%. How you get from your decimal to a percent, like going like this, you want to multiply by 100. Okay, so then the company manufactures 15,240 monitors a month. If this probability rate here is accurate for which ones are defective, how many are going to be defective out of our 15,000? So you then want to take your 15,240 and multiply by the decimal of your probability, not the percent. And this will then give you 91.44, so about 91 defective monitors. So pause the video, try this one. This will be a similar idea. Okay, so total 538 trees. Of 40 you check, 25 are maple. So experimentally, you want to take 25 over 40. And this would simplify down to 0.625 or 62.5%. So then how many of our total are going to be maple trees? Take 538 times 0.625, and you get 336.25, so about 336 maple trees. All right, so some more examples. Here for rolling 2 standard dice, what's the probability of the 2 numbers add up to 7? So I'm going to fill out this table here and go like this. So this will be the first dice and the numbers. This will be your second die and the possible numbers. So this is your first dice and your second die. And then if I fill in this table, I'm just going to add the 2 columns because we want the sum. Do they add to 7? So 1 plus 1 is 2. 1 plus 2 is 3, 4, 5, 6, 7. And this is going to follow a pattern. So then here 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 6, 7, 8, etc. So you can fill out the rest of this table. It's going to follow the same pattern. And we're going to use this for the rest of this page. Okay. So if we want how many add up to 7, it's this row right here. So there's 1, 2, 3, 4, 5, 6 that add up to 7. And then we need to divide that by the total outcomes. So everything in this square. So we have 6 by 6. If you do 6 times 6, you get 36 total options. So you'd get 0.167 or about 17% chance of getting a sum of 7. So you can try some of these other ones if you would like. If you want to do sum of 9, switch my highlighter color. We want these. So there's 4 options. So you get 4 out of 36, which will give you 11%. And you can keep doing the same idea, count which ones you have. I'll put what the probabilities are if you want to check it yourself. But we're not going to go through all of them because it would take a long time. There they are. Okay. So some more vocab. We're getting there. The complement of an event is the opposite of what you want to happen. So the not event. So opposite of what you want. So like if you were rolling a dice and you wanted 2s, the complement would be anything except 2. So your example here, if you flip a coin and you want heads, the complement would be tails. It's whatever you didn't want to happen. And then a note here, this is important. The probability of what you want to happen plus the probability of what you don't want to happen, or the complement, always has to be 100%. So a note here is this should be review. A prime number is a number that can only be divided by itself and 1 and not get a decimal. By itself and 1. So some examples, there's an infinite number, but like 2, 3, 5, 7, 11, 23, etc. All right, so last example, we have a jar with 10 red, 8 green, 5 blue, and 6 white marbles. We want to figure out the probability that a marble is not green. So here you could either add up 10 plus 5 plus 6 to get all the other colors, or you can just find what green is and subtract it from 1. So the probability of our not green marble is going to be 1 subtracted the probability of green. So we have 8 green marbles. And if we add 10 plus 8 plus 5 plus 6, you get a total of 29 marbles. So calculate this out. And 1 subtracted 8 over 29 is going to give you 0.734 or 73%. So again, you can either do 10 plus 6 plus 5 divided by 29 or do 1 subtracted. Same idea here for which one is not red. So do 1 minus 10 over 29. And you'll get 0.655 or 65.5%. So there is a Math Excel if you want to do it, or you can do this bookwork as practice.